finish grading your papers. Because, guys, life is about balance, right? Even when you got work to do, you want to try to balance that with the other stuff. All right, so if we look at our math notes. Now, guys, I do this to try to help you out, but I know some of you, like, I could be offering you a life jacket while you're drowning, and you would say, nah, I'm good. Like, seriously, I literally think some of you could be drowning, and I would throw you a rope with, like, a lifesaver on it, and you'd just stare at me. Because some of you aren't willing to put in any effort. You're not even reaching out for the lifesaver. I put these words on this paper so you have a space where if you want to copy it in your own words, what are terms? Terms are part of the expression separated by addition. This is going to be on your mastery again. It's already been on a mastery. I forget if it was one we took or one the other class took. But terms are separated by addition and subtraction. Now, really, we know everything is really addition because subtraction is really plus a negative number, right? Subtraction we could really rewrite. But if you want to rewrite that on your paper so that you can remember that, I gave you some space. There are the different parts of an expression separated by addition. So, guys, here's the tricky part. There are 3 terms in this expression right here. Because if it's inside parentheses, it does not count. So this is a term, this is a term, and this is a term. There are only 3 terms right there. The expression down in the next sentence, and some of you are ignoring me right now. Like I'm trying to toss you a lifeline and you're ignoring me. This 5 and that 2x are separated by subtraction. Really, we know that's 5 plus a negative 2x. But because CPM's definition is calling this a subtraction, they just call that 2x. But either way, there are 2 terms here. Now, what is a coefficient? Keep looking at your vocab. What's the coefficient? Read it on your own. So if you had a number like 5x, the coefficient is the 5. Even if that was 5x squared, the coefficient is still the 5. It's the multiplier to your variables. You even looking at your notes right now? Because I don't know why we have deodorant out. It's math class. The variable is the unknown part, the x, the y, the z, the a, the b, the k. It doesn't matter what letter we're using. The variables are our unknown parts. Sorry, it's back up here at the top of your vocab list. And a constant term is the number we know, right? Constant means does not change. So it's the not variable parts. The constant terms are not variable parts. Flip to the back of that front page of math notes. Sorry, the back of it. This is what we're doing today. We're going to be graphing inequalities. When on your homework it asks you about a boundary point, it's in your math notes. The boundary point is the point that gives us a boundary. Wow, it's crazy. So here 12 is our boundary point because it gives us a boundary and then we go up. Down here, 7 is our boundary point, but actually 7 does not get included. That's why this circle's open. 7 gets left out, and you can make a little note here if you want. That 7 is left out. 7 is not included here. A little sad face because 7 got left out. Although what's crazy here, 6.99999 is included. Any number less than 7. What this is showing us is any number less than 7. 7 does not work, but any number less than 7 will.
So even like negative million, like
Yeah, negative anything. Literally negative anything. Now up here 12 is included. 12 gets to go to the party. X can be 12, right? And We often just use x, but we don't have to be using x. X can be 12 here, or anything more. And you can look at these like how we got there, the inequality symbols that actually take us there. Go ahead and continue looking through your math notes. I don't need to guide you through them, but there's a lot of good examples. Take like 2 minutes. Look through them. Actually look at them. That's not good for your eyes. My uncle literally screwed up his eyes by always making his eyes go cross-eyed, by like reading too closely. Like, guys, I'm not just telling you crap. I wouldn't waste my breath. Reading stuff that closely is not good for your eyes. So equation mats, we've been doing this. Now we're going to get down to inequalities today. So now we go equations and inequalities. If we keep going, we talk about how to check a solution, how we define variables, how we can do solutions, like how we can actually figure out the solution. And guys, the back of this is just a bunch of examples of like, oh, so you're trying to solve this equation. Here's what you do. I take a lot of time to make these notes for you. Like, these don't come from CPM. They're like, this is made by me because I know what issues you're going to have when you try to do the practice for this chapter. Please use them. It's also paper, right? So if you don't use them, it's just a complete waste of trees. Please use them. They're important. No, that's even worse. The tree got cut down, made into paper, then you put it in recycling. Now there's carbon footprint that the recycling paper is going to take into the recycling plant. Then it gets shredded up again. That's more carbon footprint. Then it gets turned back into paper. That's more carbon footprint. Like, no. Use them. Like, that is the only thing to give this purpose. If you just take paper and put it straight in the recycling bin, that's a complete waste and a giant carbon footprint. All right, you should be in your ebook that hopefully you're familiar with now. You should be at, I know we skip a couple problems to get there, but problem 25 in the student e-tool. And actually, these are your directions up here, so I'll leave this screen up here while you and your partner are talking about it. So keep reading the directions up there, like especially step 4. Make sure you then look back at the board and read step 4. Are we having a conflict?
He said yes to being in the model, but he said you need to be in a ebook.
Go to problem 25. You're not quite far enough down. I'd be very cautious about doing that. Page protectors often then wipe off. I mean, if you let it dry for a while, it might not wipe off, but I would just pull it out and write on the paper. If I was you, I would throw that page protector away. What's that? No, well, that's why we use cards, so I don't have to do it. Because then it's like I'm playing favorites. Hey, if you're waiting for me, you could be working on a homework question as long as you followed all the directions that were up there. Which, if you've done step 4, then it goes back to like just the general class stuff happening. I'm not going to do this in the e-tool. I'm going to do this like we were doing it on our homework to make sure that we have some examples of how we draw this on our paper. So, here's more fun this way. Sage, pick our first card for today. It'll be funny if you pick yourself. What's the chance of Sage picking himself? 1 out of, do you know how many students we have in this class? 16 actually. This class is kind of small. Eli, what could we do first? And I know that you guys were a little delayed getting to this, but what could we do first?
Like add the -1 and the 1.
Put the -1 and 1 together, and if I want to draw this is a little tough to draw, but I could kind of do like that. So both of these are going to be gone, right? So like I could kind of cross them both out together or something like that. If you're trying to draw this on paper. Sophie, what next could I do? One block or 1x block? I'm just checking. 1 block. Okay, so one of these out. One of these out. Okay, Arfon, what next?
Get rid of 1 on both sides and 1 x.
Ooh, he gave me 2 steps. Get rid of 1. Get rid of 1x. We got to keep doing the same thing on both sides. And we're now left with x and 3. And then we got asked, okay, give 4 values that will make x, or that will make the left side bigger than the right side. Guys, on your graph paper that you definitely have, because, you know, we always use graph paper, what we're now doing here is setting up x is greater than 3. That's what we're trying to do. So for x is greater than 3, Donna, give me a value that x could be.
4, 5, 6, 7.
Whoa, I said 1.
4.
Okay, Donna said 4, 5, 6. Come on, there's no going back in time. It already happened. Jack, give me the smallest value that x could be. Ooh, close. 3.00000. As many of those as you can think of. 1. Now, how we actually draw that? Can't believe that got a laugh. My jokes don't get. It's like my jokes aren't that funny. How we do that is actually, come on, Ghost of Smart Words Past, work with me. We draw a number line. Now, if you're choosing not to do this on graph paper, that feels like not a great choice, but hey, I can only advise and suggest, and if you ignore, I can play you a tiny sad song on a tiny violin. But we are going to show x, and I've got colors I can use up here. You can grab some colors too if you want, but we start, actually I'm going to keep in white for a moment. We start by just saying, hey, here's the number I'm talking about. The number we're talking about is 3. Now we're going to say that x is what compared to 3? X is greater, right? X is bigger, X is more. How are we going to say it? But can x be 3? No. Because is 3 bigger than 3? No. 3 is equal to 3. Now this number that I wrote is bigger than 3, but I don't really even know what this number actually is. Donna, question, comment?
Well, I was gonna say you could do like the open circle.
So we start by doing a circle here and we leave it open because 3 is not allowed to be the solution. 3 is not allowed to be x. Right? 3 is not our x. So we leave this open. But then when we shade what 3 is allowed to be, what direction am I going to be shading? Numbers that are greater than 3. So like Donna was saying, 4, 5, 6, 7, greater than 3. And then it keeps going forever. So we put an arrow on the end of our shading to say, oh yeah, that keeps going because infinity. X could be infinity here. Now it can't actually, because infinity is an idea, it's not a number. Infinity is an idea. It's not a number. Count all the way up to infinity. Come tell me when you're done.
What's the number before infinity?
Infinity minus 1.
Yeah, so it's just a concept.
Yeah. It's like, so, because we can't count all the way up to it, it's an idea. It's not a number. So when we shade x is greater than 3, the circle stays open because 3 is not a solution. And then we shade to the right to show the numbers that are bigger. Questions? Hey guys, literally how I did my scribble shading, that's better than if you just do a tiny little pencil shade. Like, I can't see it if you just shade with your pencil in a straight line. If you, like, get a highlighter to do your shading, or, like, literally, you can just scribble shade it. Like, you can show me this is the part I'm talking about, arrow. Like, put an arrow on the end because we don't stop. And the arrow on the number line is not the arrow for our shading. That's the arrow from the number line. We need the arrow from our shading also. Questions? Okay. This, you can use the E tool. So if you go, I just want to show you guys this in case like you're trying to do this like when you're doing your homework. If you go search CP, now don't do like you can, I guess, I don't care. If you search CPM algebra tiles, anybody in the world can get to CPM's algebra tiles, but hold up, look up here. Look away from your computer. It's nothing right now. You would need to add a background. So the background we've been using is the comparison mat. Then you would need to add algebra tiles. And like it actually is a decent amount of work to get this set up. But if you want to use it, all you got to do is search CPM algebra tiles. It'll take you to the tool and you can do whatever you want. However, this is on your paper, so we don't really need to use that today. What we want to write on our paper is what they did to go from one step to the next step. Like that one master, we were like, oh, to go from here to here, it was the associative property. To go from here to here was the commutative property. But we're not talking properties now. We're talking what did they do on both sides. So on your paper, you should see this, the mat A, mat B. If I was you, I would draw a little fence down the middle to keep it like, hey, this is left side, this is right side. And when I do things, I got to do things on both sides. I would draw a fence down between them. Then I would turn to your neighbor and discuss what did they do to go from here to here? What did they do to go from there to there? What did they do to go from that to that? Like keep working your way down, asking what did they do? And sometimes it's just, oh, they put things together. Or, oh, they like. That's why you got partners to talk to. How did they get there? This is the most distracting seat. All the games are back here. It's hard to stay focused. I'm just slipping off. So I love what you're saying. You can say it to your partner. Okay? You guys will be talking together.
It's really -4 from out A, so you have to take
This is the church I grew up in. This is the church I grew up in. Not like I lived there, but I was there like 3 days a week. I was there a lot. Jack! Normally it works pretty well when I just say somebody's name when we come back, but I can tell you guys are still working, which is great, but like I'm just trying to be conscious of time. I'm trying to get through stuff to give you guys some homework time every day. This is my goal. Jack, how did they go from what we'll call step 1 down to step 2?
Took away 2 from both sides.
I think you're too far ahead of us. Because if they took away 2, we would stay at -6, and I don't think the next step happened. Guys, they made zeros. whether you realize it or not, they made zeros because -6, +2, you'd have 6 of the negative tiles, 2 of the positive tiles. You'd put the positives and the negatives together and you'd get rid of them. They made zeros and they were left with -4. They made zeros and they were left with -6. Any questions? And on your paper, I know I drew it in black, so it's a little hard to see. You could draw like a little bracket thing to say, hey, they put those together, right? They just put those together. They combine. So then Emory, from step 2 to step 3, what did they do?
They got rid of 2x.
They got rid of a 2x from where?
Wait, is this from like the yellow to the blue?
Blue to whatever comes next.
Oh, they got rid of
You're
the
right.
-4.
No, I think they got rid of the. I like what you said the
I don't
first
know where
time.
we are.
You're right. They got rid of 2x. I was just trying to get you to say on both sides.
Yeah, they got rid of 2x on both sides.
Yeah, they got rid of 2x. Guys, if I was you, I'd write this on your paper. That what they did was -2x, -2x. They got rid of 2x from both. They just did the same thing on both sides. Take away x, take away x, take away x, take away x.
Sorry, I knew that.
You said the right thing. Come all after this step, what did they do? How do you get rid of how does -4 go back up to 0? You add 4. So what I would write on your paper is they added 4 on both sides. Shaw loves that. You see her out in the hallway. Actually, she doesn't care anymore, really, because she has realized like I have spread that word. But I told her she's helping you guys remember on both sides, because that's like the #1 rule of algebra is on both sides. Safe. We got one more step, I think, maybe, because they got down to the purple. 3x equals or 3x compared to -2.
They took away the.
You're not looking at your page. Sorry, I didn't realize you were like up and back there. My bad, dude.
They took away 4 from the negatives.
So they already did that. They added the 4 to both sides.
Oh, so last step.
Yeah, they have 3x compared to -2. What the heck would we do now, right? Like what?
I thought you were on.
Oh, I know.
So like they just stopped, right? They got to 3x, they got to -2. Now, if we want to actually push this one more step, if we knew, I mean, sure, yes. If we knew what x was, that would help us. But what if I tell you that actually 3x is equal to -2? And this could go on your graph paper, and this could go somewhere off to the side. How could I get from 3x back to just a single x? I want to go from 3x back to just 1x. What can I do? Talk with your neighbor real quick. See if you can come up with an idea. James, you guys come up with anything? You say no. Devin, did you guys come up with anything?
I did.
Ooh, you want to throw? Eli's shaking his head real hard. You want to throw it to him?
So this is by 3.
This 3x is 3 times x. How do you undo 3 times? We can divide. So really, x, if we get told that these are equal, hey, Ray, what are you doing, man? Huh? Okay, but this is not on the algebra tiles thingy. I'm teaching you something right now. Again, we might need to move where you sit. If we want to get rid of 3 times, we can do divide by 3, because what's 3 divided by 3? 1! This, I really want to be in a different color. This becomes 1. But I have to do it on both sides. So this side is still -2 over 3, which honestly I would leave that as a fraction. I would not do anything else. I would leave that as a fraction. Let's try this one, and I think it'd be better for us to just do it on graph paper. I don't think I put the. Okay, so this is no, not this one. This one is not on your handout. We're gonna write this down. So graph paper question mark or graph paper exclamation point.
Exclamation point.
So we're gonna do Mat A and Mat B. Now you can use the E tool if you want, but you gotta drag a bunch of stuff over and you gotta do a lot of things. Like you can use the E tool, but honestly, I think it's just as easy to just set it up on our paper. I said the bad word. No one caught me.
Oh, you said a bad word?
Just say simple. You should have 5.
You should have heard the misters.
If we have a left side and a right side, we should put a fence between them. Keep things straight, left side, right side. I want you and your partner to try to figure out what to do, just like the problem we just looked at. How do we clean this up as much as possible? Now, if you can't figure it out, you can go to your algebra tiles, use those, like that's fine. But I think if we just look back at that previous problem and look at what we wrote, like, oh, they made zeros by like putting those numbers together. They did this on both sides. Like, check out what we just looked at to help you with this one. Go for it. No, wait, are those your negatives? Click them, yeah, click them and flip them at some point. I mean, if you're waiting for us, you'll be working on homework. Yeah, if you're waiting. All right, we got to remember there are lots of different right ways to do this. So Ashley, can you tell me what you did first? And this might not be the same as what you did first. There's a lot of right ways. Ashley, what did you do? Yeah, put together our constants. 2 and -3 can be put together. And if you set up an algebra mat, you'll see, oh, those are all ones. Those are red, those are blue. So when I put those together, what do I get? 2 plus a -3. -1, right? -1. And then I still have 2x. Did you do the same thing on the right side, Ashley? Sweet, because we got constants over there too. So -4 and a +1. What's -4 and a +1? -3. Okay, sweet. Thank you, Sophia. I keep calling people and moving around. Sophia, what can we do now? And I know this maybe wasn't the route that you took, but what could we do now? Take away the 2x's from both sides? Sure. Take away the 2x's. Now, guys, we want to write this down so we know what we did. I know you could just jump to writing down your next step, but writing down the in-between is pretty important. Lane, do you know what you guys did? I know it might not be the same path you took, but if we have -1 and -3, so how do we get -1 back to 0? Add 1, right? We talked about this, I forget it was yesterday or 2 days ago. But if you want to destroy this, taking it away, what you're really doing is adding a +1 to both sides. Yeah.
Would the right side be larger because it has more negatives, or would
Well, so hang on. So that's a great question, but hang on to it. So now we get 0 compared to, what's over here? Which would you rather have? No money or owe someone $2? So this is a case where 0 is greater. Even though it's 0, 0 is greater than -2. Questions? So if at this point, what if we add 2 to get rid of these -2? We also have to add 2, and that will give us 2 compared to 0. It's the same thing. You just did more. You can do anything, and there will still be a difference of 2. Right? You can do anything, and that side's still going to be 2 bigger than that side. 1 and -1 are still 2 apart from each other, right? So you got the same thing. Guys, there's a lot of right ways to do this. You could add 400 on both sides. I don't know if it's all that practical, but you could. All right, so let's skip to 27. Let's do one more, and this is on your paper. This is on your paper. But it would be really good if we write it down and actually show what we're doing. We need to get x by itself. And then once we get done with this, we're working on homework for the last couple minutes. You guys want me to go ahead and start asking questions so we can get through this?
Yeah.
Bethany, what could I do to start getting that x by itself? I'm going to give you a hint. Deal with the constant first. Deal with the coefficient last. So the constant is the number without the variable. Deal with the constant first. How would we get rid of that +5? How do you take +5 back to 0? So what we want to do on both sides is minus by 5 to get rid of the pot. We're taking away 5 tiles. And now what is weird is to do that, and if we do this in the algebra tiles, like on CPM, it might not totally make sense, because do I have 5 tiles to take away over here?
No.
Not really, but can I do 3 minus 5? Yeah, we just end up negative. Negative what?
2.
If you're choosing not to write this down, it feels like not a great choice. Ezekiel, if I have 2x, how can I take that back to a single x? Yeah, divide by 2. Where? On both sides. And we get x. How do I say this? No. Is less than. What's -2 divided by 2? No.
-1.
-1. Now, how do we graph this? So you have another example on your paper. Draw your number line.
You draw like -1 in the middle.
-1 is the number we care about.
And we draw a circle around it. Right or no?
We're going to make our boundary point. Is -1 included?
No.
No, because we do not have the or equal. Remember, if we had the or equal, it would be included, but we don't, so it isn't. Then, to show x is less than -1, which direction would I shade? Left for less than. And you have the rest of this time to work on your homework. Sorry, Raiden, Sam, and Carolina. You're the only ones that did not get to. You're going on top for tomorrow. So I know your heart is broken that I did not call on you today.
I'm so sad. I can't believe you've done this.
I did nothing. Fate. Fate and probability. Hold on, I'm going to stop the recording real quick just to make it.